Hi everyone, welcome to this session. I'm going to discuss about big data within this video. You may heard about big data in different resources, internet, your classrooms, from your friends, from your employer, and so on. But we need to know, we need to understand what is big data exactly. The first things comes on mind is about the size of the data. So when we talk about big data, we are talking about huge size of data, massive amount of data, and the size of data that's going to be beyond megabyte, gigabyte of data. So let's say you have 1 GB or 2 GB Excel file, and this Excel file is your day-to-day file that you want to work with that file, but now it's going to be 2 GB. So let's say you want to calculate the profit loss out of your Excel file because your Excel file is related to finance. So to do so, first of all, you need to open the Excel file. But since the size of file is 2 GB or 3 GB, it's somehow impossible to do that. If you double click on the file, your system is going to be crashed, right? There is a big reason that why system is going to be crashed and your file never is going to be open. So the main thing is CPU and memory, they are not capable enough to handle your huge size of data, right? So we could find the reason. CPU and memory, right? CPU and memory, these are the main, let's say, the main problems for handling huge size of data. So we have to find a solution. We have to find a way to see how we can handle this size of data. But in terms of big data volume, it's not only a case to discuss about the big data. We have some other approaches, or let's say other ways that we have to take them into consideration, because big data is not only about the size of data, uh, but only discussing about new forms of data, like data generating at second. I mean, we are talking about velocity, or data is going to be into different formats. We are talking about diversity or variety, or also we are talking about the completeness of data, means we are talking about the accuracy of data, and also about the worth of data, the value of data. These are all, the V's. We call them 5 V's, right? I mean, the combination of these V's. That's going to take big data as a new challenge that we need to take over a new technology to handle these sort of new type of data. So let's move forward and let's see what exactly we need to do. So as I discussed, the problem here is about, the data storage and also the time taken for processing and collecting massive data, right? So the thing is, when you have data, let's say you have 1 TB data, right? So in this case, you can have about, let's say, 5 TB hard disk, right? And then you can simply store it inside your 5 TB hard disk, right? It's easy, right? It's not really a big problem. The problem is when you want to process, right? When you want to process. So processing is the problem. So when we want to process means we need to have computational units, right? The computational units will be CPU and memory. These are the main resources that we have to take them over. So organization need to have effective data analytics solution, right? In terms of data storage. And in this case, let's say your data is going to be collected every second. Let's say Google. Once you open, Google, and if you want to look up a specific keyword, you are not the only person looking for that keyword at the same time. I mean, at this time, right? So millions of customers, billions of customers around the world gonna to use the same service to look up a keyword, right? So let's see how Google is gonna to collect these amount of huge size of or massive amount of data across the world, and how gonna to manage all those data, right, within a second, even within a millisecond, right? So the first challenge is gonna be data storage. So how we can store those data, right? So and the second one is going to be like the ability to process near real time with low latency. So again, in Google, if you look up a keyword like, let's say you want to look up big data, right? So once you press enter, it's going to take, we can try it right now. So if you say like google.com, right? And if here you say big data, right? So as you can see that it took less than a second, right? And comes up with this number of result. So how is that really possible to have this, this result at real time with low latency? It means it didn't take time, right? Just less than a second. So there is a technology behind that, and we are going to discuss about that technology. So to be able to understand big data, as I said, we need to consider these V's. I mean, we usually get these 4 V's like volume, velocity, variety, and veracity. Of course, we have another one we call about the value, and value is very relevant to veracity, means the completeness of data, right? So let's see how we can, go ahead with these keywords. So volume. So we used to work with this usually with this amount of data, right? This is the actual size, let's say day-to-day files that we take over and we work with them. So let's say from gigabyte to yottabyte, the size is going to be increased, right? So, we usually call, this part we call big data, but please bear in mind, big data is very relevant to your resources, right? CPU and memory, right? So let's say on my own machine, maybe I can and I'm able to open 2 gigabyte file by doubling click on the file because I have, let's say, about 512 gigabyte memory. I have about Core i, let's say Core i19, right? These are really well enough to handle 2 gigabyte file. But maybe with your own machine, it's really impossible even to work with 2 gigabyte size of data, right? So, in this case, we are not going to pay a lot and to buy a machine. Maybe you want to say, okay, if my machine is not suitable enough, it's not, is not enough to handle my data. Okay, I will go to market. I will go. I will double check, the available memory and CPU that I can purchase from, from market, and then I can work with my data. But really, this is wrong because you are not forced to buy new requirement, new, hardware requirements, because working with big data doesn't mean that you have to pay a lot. It means you have to take into consideration new technology to still work with your own same hardware, the hardware facilities that you have, right? This is the thing we have to consider. So let's say if you're working for a company and the company is, they are used to working with like 10 terabyte data per week, right? So, but you have about, let's say, 4 or 5 machines across the, organization. And the thing is, we shouldn't ask, your manager or your boss to say, okay, since the data is huge, we have to buy the hardware, right? It's wrong, because if you go to the market and buy hardware for 10 terabyte data to be able to handle 10 terabyte data, if your data get increased by 20 terabyte, so what do you want to do? You want to go again to the market and buy additional resources? No, this is really not well organized strategy, right? The well organized strategy means we have to getting used to work with new technology, right? We call big data technologies. So in terms of velocity, so it's going to talk about how data is going to be created or how it is going to be collected within a millisecond, right? It's talking about the speed data, right? Speedy data. So let's say Facebook, Twitters, I'm just giving you example of big companies that, of course, they have, they're gonna to have like the event files, like log files, warning files, that they're gonna to collect them, right? To be able to handle authentication, authorization, and also the privacy of, the user data. So how they collect all this data together, because they are generating, every second, a huge amount of data is gonna be generated. I mean, within less than a minute. So how they gonna handle these huge amount of data? Even if you, if you wanted to copy a file from, let's say, from your own local hard disk, from drive C to drive D, if the file is about, even like 50 megabyte, it's going to take about 1 minute, right, to transfer from drive C to drive D. So but this is 50 megabyte or 100 megabyte. We are talking about gigabyte of data, right? So we have to think how we can deal with the right velocity. This is the second component of big data. So, and you know the reason. What is the reason? I mean, these are not capable enough. I mean, memory and CPU, they are not capable enough to handle this amount of data within a second or less than a second or even less than a minute. So if you want to deal with this speedy data, you need to consider, these three classifications. Let's say in terms of your requirement, your data gonna be batch and periodic. It means we have well enough time, as you can see here, we have well enough time to handle these kind of data, right? Let's say we have been set up, let's say many sensors, right, across, let's say across a high school, right? Let's say in environment, let's say in the city, we have about 10 high schools that we want to get the control of people passing over there. We want to get, the temperature of, the weather or the temperature of, anything around high school to avoid firing and so on, right? So it means we need to set up sensors. Let's say in this case, maybe it doesn't matter to, to be very to act at very real time, right? Because we are not working with very, very dangerous and very high priority actions. Except the fire detection. So, in this case, you can set up your environment, right? And you can collect your data, and that we call it batch because we have well enough time to collect those data, right? Let's say we collect those, data every hour, every 2 hours, every 5 hours, right? And then you can put it in the periodic format. Let's say every 4 hours, every 5 hours, we can process data. You can use machine learning. You can use a statistical analysis. You can use visualization. You can use whatever you want on top of data, right, to convert your data into information or knowledge. It means we have really well enough time, like 4 or 5 hours. But for some other cases that we need to act at near real time. So, we have to process within a minute. Let's consider antiviruses, or let's consider IDS, intrusion detection systems, right? Or firewalls, right? Let's say for this typical, security measurements on threats and vulnerabilities that we usually use. These stuff like IDS, firewalls, ACL, and whatever you want to call for this, security measurements. So maybe responding to those traffic within a minute is reasonable. Let's say in a company that I'm working, uh, I have no any confidential data, right? We have no any confidential records. So, but I mean, maybe 20% of, the organization data are gonna be confidential, right? So maybe in this case, you can consider near real time, processing. So it means you get data from outside your company, your networking, and from external links, and then you want to process those data. So, but in terms of your security measurement, firewall or IDS, they're gonna to detect, okay, there is a malicious traffic, or there is, anomaly traffics, right? So you may need to put it into near real-time action. Otherwise, your infrastructure, maybe it's going to be damaged, and also you will lose your confidential data, right? And real time, it means you have to react within a second, like Google. Just we look up, the keyword, and it returned result, less than a second. It was 0.5. It was about like 5 milliseconds. So, we need to learn how to work with technologies, right? New technologies, to be able to handle or speedy data across these three classifications, like batch processing, near real-time processing, and real-time processing. So if you want to compare batch and streaming processing, right, you would see that in terms of batch data, so you can process all data, right? Let's say you get data, you have well enough time. The first example I said, you have like 4 or 5 hours. Time slots to process your data. So in this case, you can handle all data. But if you have streaming data, means you get data like a gigabyte data, a 10 gigabyte data per second. So really, it's impossible to store like 10 gigabyte data within a second, right, into hard disk, even into the memory, right? So you have to have like windowing solution, or you need to have some streaming processing, strategies on data to be able to, get a specific pattern out of data, right? Like if you have like 2 gigabyte data processing within a second, maybe you need to just get like 10 megabyte of data out of 2 gigabyte of data. So we call it rolling time window. So different really strategies to handle streaming data, because this is the new generation of data type, streaming data. So data size, large batches of data. But in this case, for streaming data, as I mentioned, since we have to work with data at a second, right? So we have to think about micro batches, to be able to handle data in a few seconds. So latency, minutes to hours. Let's say you want to train a data using machine learning. It doesn't matter to take like 10 minutes or 2 hours or even 1 day, right? Latency doesn't matter on batch data. But for streaming data, latency is really important, seconds to milliseconds. So as you could see that we can't use machine learning for streaming data. If you want to use machine learning on the streaming data, means data generating at real time, or data is going to be collected at real time. So you need to convert or transform machine learning from batch, format to streaming format. That's really difficult task, but very interesting area for machine learning. So analysis, you can have complex analysis, means for instance, you can use PCA, TSNE for visualization. You can have feature reduction. You can have very complex and very time consuming machine learning techniques like SVM, like like neural networks, you know, and anything that's going to be complex analysis, right? Because time is not important, right? Time is not important here, but time is important here, right, for streaming, because we have no well enough time, right, to handle data or use PCA, right, or feature or multidimensional reduction techniques or feature selection techniques, or you know, or any other techniques that's going to take time. So in this case, you have to think about, you know, small tasks on the streaming data, right? Like using simple response function, aggregate the result, rolling metrics, to just make sure that you can, you know, process data within a second or millisecond. So streaming data, it's new area, new generation of data. So, and you need to handle, you know, this data with new technologies that you may heard or you want to hear about that, like Kafka. It's gonna be like, I mean, let's say the tools or methods that you can handle huge size of data. This is just for example, right? Kafka, or even, you know, streaming processing in Spark, right? That we, I mean, we can specify. So another approach here is variety. So we used to work with the structured data, right? I mean, tabular data. I mean, Microsoft SQL, MySQL, and Oracle, and you know, many more, right? So because these are easy, right? These are easy to work. But nowadays, let's say we have to work with, you know, new type of data like unstructured data, because data is not going to be only in the tabular format. You have data in the form of photos, videos, audios, text, and maybe you want to use like Amazon's services like S3 service, Amazon Redshift service, and many more, right? These are a type of data we call unstructured, means there is no pattern, no structure format, right? And another approach here is called semi-structured. So semi-structured is going to say, okay, we are going to take advantage of structured data by getting the schema, I mean the column name, but the data itself is unstructured, right? I mean, this is very well known, I mean, data type that we usually use with JSON file, with CSV file and XML file, and many more, right? So why we need semi-structured data? Because the thing is, semi-structured data, you can keep it inside the file, right? CSV file, JSON file. Reading and writing, I mean, let's say reading a record from semi-structure or writing into the semi-structure is much, let's say, taking less time as compared to reading data from structured data from databases or writing data into the databases, right? So that's the reason these are really nice data type and we usually handle. So, I mean, as you could see that we have really different type of data like structured, unstructured, and semi-structured. And we really need the platform to be able to put them all together and process data. We haven't had this chance before. And we need really new technology to be able to work with this, you know, variety of data. So, I mean, this technology should be really user friendly, right? And be efficient in terms of, you know, processing. So how to do so? We want to discuss that. Who is going to handle? And veracity. This is the last one. So veracity is going to talk about the accuracy, right? Let's say the completeness of data. So these are, let's say, a bunch of sources can affect on your data quality, right? We have to collect data noise-free, abnormal-free, not duplication, accurate, no error, right? And so on. Let's say you want to measure, let's say you want to measure the height of, you know, I mean, schoolboys or school girls, right? Let's say across, just let's say UK. So if you want to measure, there will be, of course, human error for the measurement, right? So this measurement is going to be like act as an outlier or as a noise, right, for your data. If you want to collect this amount of data across UK schools, just imagine how much of data is going to be inaccurate, or let's say incomplete, because there is a human error for the measurement. So, or let's say you want to collect the network traffic, right, for anomaly detection. So network traffic itself includes incomplete data, incomplete traffic, or let's say is going to have breach of regulation for, I mean, for threat and vulnerabilities. So this is another source. Or maybe you want to use a statistical analysis to analyze, like, I mean, your data. So statistical analysis itself has a bias, you know, for measurement or for analytics. Or let's say you have null values, you have data that's not available even, right? So how to handle all this stuff together, right? Again, we need the technology, we need a platform, right, to be able to manage all these, you know, this bunch of problems, let's say bunch of issues, right, for data processing. So these are all, I mean, discussion that's going to say we need new technology, right? So, I mean, this technology, the first technology that has been, you know, has been developed was Hadoop, that I'm going to discuss about that. So knowledge check. Okay, let's do this practice together. Okay, I want to give you, you know, a few seconds to read this scenario, and we want to say that based on this scenario, which of the following ways provide this challenge, right? Because we have to find, I mean, what is the problem really? Okay, the scenario is my business has a set of 15 JSON data files that are each about 2.5 gigabyte. So this one is going to talk about volume, right? Because 2.5 gigabyte multiplied by 15 is going to be really huge data. So volume is the problem on this scenario. They are placed on a file server once an hour. Means every hour we have to collect about, like, I mean, 40 gigabyte data. So this is talking about velocity, right? And hour. So you can consider this, you know, velocity in terms of batch or periodic processing, right? Because it depends again. If you wanna, I mean, if you wanna have very complex analysis, maybe an hour is not going to be well enough time, you know, to put it into the batch periodic and periodic, I mean, uh, time slots. Maybe you need to consider it as the real-time processing. It really depends on your case study. So they must be ingested as soon as they arrive in the location, still velocity. The data must be combined with all transactions from the financial dashboard for the same period, then compared to the recommendation from the marketing engine. So as you can see, that is going to talk about variety, because we have JSON file, right, which is semi-structured data. And here it's going to talk about the transactions, right, from financial dashboard, right? It's going to be at any format, right? So we can say there is also variety problem. So all data is fully cleansed. Okay, means, I mean, veracity is there. We don't need to be worried about that. And the result from this time period must be made available to decision making by 10 minutes after the hour. So still talking about velocity. So as you could see, this scenario is going to talk about, you know, this problem: volume, velocity, variety. So for big data, you need to find which category is your main problem. I mean, within these four categories: volume, velocity, variety, and veracity. So the second scenario, let's read together. My business compiles data generated by hundreds of, corporations. Still talking about volume, hundreds of corporations. So this data is delivered to us in very large files, transaction updated, even data streams. So can you see that these are different data type, right? A large file. So it's talking about, variety. The data must be cleansed, right? It means we have incomplete data. We have not accurate data. So we have to consider veracity as well, right? So to do not skew the result, knowing the data source for each record is vital to the work we do. Okay, a large portion of data gathered is irrelevant to our analysis. So this data must be eliminated. This is still talking about, veracity. The final requirement is that all data must be combined and loaded into our data warehouse. Still talking about variety, where it will be analyzed. Okay, so as you could see, there is no any speedy data or speedy, analysis. That's the reason velocity it's not a part of this scenario. So, let's take you into the example to really understand. Okay, just give me a second. To understand where is the problem. Okay, let's say we have 5 terabyte data. I want to give you, a real life example to see why memory and CPU really they are not capable enough to handle your huge size of data. Let's say I have 5 terabyte data, right? So, and the speed of your machine is 200 megabyte per second, right? This is like very, normal PC, ordinary PC that we usually use. So how much time will take to process these 5 terabyte data? Okay, we can simply, calculate. So for processing, since this is 200 megabyte per second, right? It's better to unscale it by say 200 multiplied by 60, right? Means we remove the second. We remove this second, right? The timing. So, but since here 200 is megabyte, we have to convert these 5 terabyte to megabyte to put them into the same scale, right? This is gigabyte and this is megabyte. Okay, so it takes approximately 437 minutes to process this data. But you know that it's really impossible to do. So it means you have to open data. So, even if you double click on data, your system will be crashed. Okay, so, or let's say you have, you want to process this file using Python or using Java, right? So first of all, you have to load data, right? So once you want to load data, let's say with pandas in Python, or you want to read data using CSV read file, again in Python, or with Java, with R, with MATLAB, with any programming language, your platform will be crashed again. Because 400 minutes, it's really impossible to do so, right? So what we have to do, what is the solution? So, the initial solution is going through these things like scale up and scale out. So scale up means, okay, since you have this machine, let's add, extra, hardware. So, but it's really expensive, not possible to do that, right? Because let's say if you have 10 terabyte data, even these 5 terabyte data, right? So let's say, okay, you have to buy hard disk, well enough. So, but if you want to buy a hard disk, you have to make sure the hard disk is, is compatible with your, with your motherboards, right? So maybe in this case it's easy, but if you, if your size the size of your data is going to be increased, then you have to add more hardware. Even in this case, right, if you get the maximum available CPU, the strongest available, memory on one single machine, still impossible, to handle your data. It takes time. And as I said that at the beginning of this video, it's really not organize a strategy to, to go into the market and buy additional hardware, right? For just having 2 TB of data. That is really just you wanted to analyze your day-to-day data. So scale out means let's add more workstations. Let's add more workstations. So again, expensive. Fault tolerance means if one machine stop working, so you will lose a part of your data. Development problems means you need to have a networking background. Means you have to, you have to get switch, layer 2, device, and also you need to have router, layer 3 device. Guys, these are for networking, guys. If you have networking background, means these are requirement, right? These are devices that you have to purchase to be able to handle, and a local a local network. So still not possible. You need to spend a lot in terms of time and money, right? Still not reasonable. So, but what is the best solution? We are looking for something like this, parallel processing. So parallel processing is the answer to these questions: how to process big data, how to process massive data, how to process streaming data, how to process different type of data, right? With the consideration of the size. So let's say, how does it work? Let's say this is my 5 TB data, right? So for parallel processing means we have to add workstations, means I have to buy 5 workstations and divide data into these over these machines, like 1 TB here, 1 TB here, and so on. And still the speed of this machine is same. If you calculate the time taken to process 1 TB data, let's say you have well enough resources, to handle, CPU and memory. Again, it takes about 807 minutes, right? Since these are running in parallel, so the total time is going to be, 87 minutes. There are some, it seems nice because the only, technique that you can handle big data is parallel processing. But there are really some, shortcomings. For instance, the first question is, let's say you are coming with, accounting background. You are coming with engineering background. You are coming with, let's say agriculture background. So, or even computing background, right? You need to have this knowledge to how to divide data. So divide data is the first problem. This one, right? This division, right? We have to divide. Takes really time, right? You have very simple data. You want to just calculate the profit and loss, and you have to think to how to divide data. The second problem here is costly machines, right? You have to costly machines, right? You have to buy 5 workstations. And the second problem here is parallel processing, how to set up, how to write a code to be executed in parallel, right? Parallel processing itself is the problem, right? In this case, you have to write the code even in Excel. Let's say if you, as I said, you are coming from finance background, so you are, how to work with Excel, but you don't know how to work with Python, right? So in this case, you have to write a code to be executed in parallel. So how to convert your code into the parallel format? This is really another big problem, right? That we have to take into consideration. And the last problem I can see here is the aggregation of the result, right? After running them, into parallel mode, you have to, aggregate the result. So aggregation is another problem. Who is going to aggregate? How to aggregate? Where to aggregate? So which aggregation method we have to apply? And so on, right? These are really the problems within parallel processing that to solve them, you have to pay or you have to have more knowledge. I mean, this combination is really worst combination because you are not going to take them over. So how to put them all together, right? How to put them all together to, let me take you here, how to put them all together, right? This dividing and distribution problem, parallel processing problem, combining result problem, and costly server. How to put them together to be free, open source, right? How to put them to be free and open source, new technology. How to do so? Hadoop. So Hadoop is a technology is going to handle these 4 problems, or let's say these 4 challenges, to make sure you can handle your data, right? So let's move forward to see what is this Hadoop. So Hadoop was created by computer scientists Doug Cutting and Mike Caferea, right, in 2006. So they got the idea, right, from Google File System and Google MapReduce. That, I mean, they got these, I mean, ideas from, you know, these Google services. But maybe it's really interesting for you to know who named it Hadoop. So Doug Cutting's son, he had a toy, I mean, elephant toy, right? And this guy, Doug Cutting, got this inspiration from his son toy, because his son called his toy Hadoop. And that was the reason, you know, this name come from his boy, or let's say his son, his son's, you know, elephant toy, right? That was called Hadoop. Okay, what is Hadoop? Hadoop is an open source framework, right? Written in Java. So because Java is really fast and very accurate and robust programming language at compiler stage. So usually compilers is running under Java programming. So, and the first version, Hadoop version 1, was proposed on November 2012, and as a part of Apache project sponsored by Apache Software Foundation, right? The latest stable release is available here, right? If you want to check Hadoop, Apache, and then, okay, Hadoop. Now we have to see what is Hadoop. So Hadoop has 2 components, HDFS and MapReduce. Let me take you here on my whiteboard to discuss about, you know, Hadoop. So let's say we have 1 terabyte data. But let's say we have, I mean, 1 gigabyte data to make sure, I mean, I can propose all samples here. Okay, we have 1 gigabyte data. Let's say we can't work with 1 gigabyte data because of the size. So how to work with this data? You have to, I mean, store it into hard disk in the parallel format, right? So, I mean, we have to have this, you know, approach, because we have to set up this configuration all together to make sure these are all achievable. Okay, how to do so? Let me show you. Okay, I have 1 gigabyte data. Let's say in my own PC, I have 1 PC or 1 laptop. I want to work with this 1 gigabyte data. I don't want to buy additional resources. So let's say in my machine, I have, let's say I have 1, you know, this is my hard disk, right? This is my hard disk. Okay, so I want to divide them. I want to divide data into 4 portions. 1, 2, 3, 4, right? portion 1, portion 2, 3, and 4. So it means it's going to be 205 megabytes, right? 250 megabytes, and so on, right? So hard disk we call data node, right? Because it's going to hold data, it's going to keep your data. So since we got this data into 4 portions, so we have to record them somewhere to say, okay, this data has been distributed into 4 partitions. So we have, we have a node called name node. Name node is going to keep the track of, all these metadata, right? Let's say name node is a metadata. It's going to say, so where they are, the location of data, right? The size of each partition, right? The number of partitions, right? Also, it's going to talk about, and also it's going to keep like how many replication, why we need replication once you miss or once you lose a partition of data. So the default replication is 3. It means, each partition is gonna have 3 replications, right? If you miss one partition, still you don't need to be worried. You have still another replication. Let's say, for replications, you can keep them, you can store them into another machine, right? In the case of if you lose these hard disks for any reason, right? You still have replications. So and many more information, right? Which gonna come up on name node. So since name node is really important component, because name node is the metadata that you can get access to your actual data, right? It's going to be executed on memory, right? On RAM. But your actual data is gonna be executed on hard disk. So if you miss name node, this really important. That one is really important. If you miss name node, right, for any reason, let's say you delete it manually or automatically, for any reason you miss that name node, it means you will lose your whole data because data has been divided and you cannot read your partitions, right, without this name node. So to be able to read partitions, you need to have access to name node. Okay, this is what exactly we call HDFS, Hadoop distributed file system, right? Which is name node and data node. So name node we call master node and data node we call slave node. And these are the components. Let's see what they do. Name node keep all namespaces in memory, maintain metadata, monitor data node health, replicates missing blocks, and many more. Please make sure to read all this information over these slides. And data node serves data blocks, handles block storage, periodically send heartbeats. So data node is going to send heartbeats every second to name node. Why? Because it's going to say, okay, I'm live, I'm still there. There is no any problem, there is no any hardware issue, and I'm still alive. So name node can understand data node is alive. And store blocks, as underlying operating system file. So, okay, this is about data, right? How to store data. So, okay, we learned to divide data into partitions. So Hadoop is going to take it over and divide your data into, here. Hadoop is going to take over your data, right? 1 gigabyte data, and then put them into 4 partitions, right? Hadoop did that perfectly. So now how we can process, right? Let's say this data is a text file, is a log file that you want to look up a specific keyword, right? Or let's say you have a log file, you want to calculate the number of unique words or to count the number of unique words. Like let's say a specific processing you may have. So in this case, I want to show with another color, let's say with this color. So in memory, we will have a component we call job tracker, right? Job tracker. So job tracker, is a node. It's going to get your job. So you can write your job in Python, in Java, in R, with MATLAB, with any available programming language or platform you may have. So job tracker is going to take over your job. Then job tracker is going to divide your job, that we call it task tracker. So task tracker. So it's going to put one portion of data here, one portion here, one portion of your task, and so on. It means your job has been divided into 4 partitions. Do you remember I've said the one problem in big data parallel processing is how to convert your code into into the tasks. So Hadoop is going to take it over and put them for each partition. So then Hadoop is going to execute them in parallel, right? Because this is parallel processing, right? And this stage we call mapping, right? And then afterwards is going to collect data and aggregate. Also, if you remember, I've said the one problem is aggregation. So Hadoop is going to aggregate that. In this case, we call reducing phase. So for processing, we have one node here, job tracker, one node task tracker, and mapping and reducing, right? So also in this case, task tracker is going to send heartbeat to job tracker. So it means task tracker is going to send heartbeat to job tracker to say, okay, I'm live and I'm working. These tasks are running in parallel, right? There is no any problem. But if there is any problem, let's say one node or let's say one partition is going to be died for any reason. Let's say there is a hardware issue, right? Usually it's based on, because of hardware issue. So hardware failure. And then task tracker is going to send a heartbeat to job tracker to say, okay, just node 1, 3, and 4, they are working. Then job tracker ask name node, I'm looking for a replication of partition 2. Then name node is going to find where is it, and then is going to send back, to the job tracker, and then job tracker send it back to task tracker to say, okay, task tracker, for instance, we have the replication of partition 2 within the same hard disk, and task tracker is going to create another mapping here, right? Another mapping here, and make sure they are still running in parallel, right? These are the process. Also hard disk is going to send heartbeat to name node, right? And to say, okay, I'm working, I'm live, and there is no any problem. So as you can see that name node is somehow a metadata, or let's say a master node for data node, and job tracker also is somehow, master node for task tracker, because job tracker should discuss with your resources to find out how to distribute this processing. Okay, job tracker, as you can see that a coordinator for tasks, right? It keeps track of jobs being run on cluster and so on. Task tracker, as I said, that mapping, reducing, and shuffling is a part of reducing, right? I will explain that. What is that exactly? So MapReduce components. So please go over this, go over this slide deck. It's going to talk about job tracker. What exactly I explained on this? On the whiteboard. You can take it here, right? Client submit job to job tracker. Job tracker talk to name node to determine where is data, and so on. and task tracker, how does it work, and about the heartbeat, right? All this stuff have been explained. I mean, I just went through them through whiteboard, and make sure to read them out. And this is the whole schema, right? Hadoop schema, and you can see that the client firstly should, I mean, should first store data, right? So name node is going to get, let's say we have 3 machines here, right? Or let's say, guys, here you can take them 3 hard disk 1, hard disk 2, hard disk 3, right? Or you can consider like workstation 1, workstation 2, and workstation 3. So it means you can have 3 hard disks and you can keep them within your own machine and still run Hadoop. So then job tracker, the second phase, we call it MapReduce phase. It's going to get your job, I mean, from client, and it's going to divide data into task tracker. And this task tracker is going to run map and reduce, as I explained. And also heartbeat signal is a processing, I mean, is the part of this processing is going to be come up from, I mean, task tracker and HDFS to the master nodes. So as you can see that these are really important, name node and job tracker. And these are job tracker workflow. So we discuss about these steps. Please make sure to read over and make sure to grab all the points. And these are task tracker workflow. And also, I mean, I've explained all this stuff, and make sure to go through it. So in I mean, in MapReduce version 1 that I explained, you know, the mechanism, we had the big problem. The big problem here was, I mean, all processing is taken over by job tracker. So job tracker is the JVM machine. So as I said, Hadoop is, I mean, has been developed by Java. It means this is a JVM machine, right? Name node also another JVM machine, and data node another JVM machine. So these are, you know, there are many JVM machines, Java virtual machines, that going to be run under Hadoop umbrella. So in Hadoop version 1, if you miss job tracker, it's going to be really bad. If you miss name node, it's going to be really bad because you will miss your cluster, right? You will lose your cluster. So, I mean, also job tracker is responsible for all the processing tasks, like finding available CPU memory, divide data, resource allocation, and job management, and many more, right? So for that reason, in Hadoop version 2, we came with this idea that it's better to divide, or let's say it's better to separate these tasks, right? For that reason, we have this, you know, new version of, I mean, map and reduce. We call Yarn, yet another resource negotiator, right? This is, we call in Apache Hadoop 2 and 3. I mean, if you install Hadoop 2 and 3, it's called Yarn. So if you look at here in Yarn, we have something like that. Resource manager, I mean, in Hadoop version 1, it was responsible for resource management and job scheduling and monitoring. But in Yarn, we have something else. In Yarn, let's say if you have, I mean, workstation 1 and workstation 2, right? So it's going to create the new JVM called node manager and another node manager here. Create container JVM, another container, and application master and application master, because it's going to divide its own responsibilities across the cluster, I mean Hadoop cluster. So then we have this stuff. Resource manager knows where data node and slave nodes are located. We call rack awareness, right? And how many resources they have. So it means resource manager is going to talk with your hardware to see, okay, I mean, it's going to talk with the operating system, right? Because I mean, in this case, let's say maybe the operating system of workstation 1 is different with workstation 2, or maybe they are same. Let's say they are Windows all, Windows 11 or 10 or whatever. So it's going to discuss with them to find out how these resources are available. Then node manager is going to care of individual compute nodes, keep up to date with, resource manager, and is going to send heartbeat to resource manager. And container is a fraction of computation resources. So container is going to get updated every second in terms of CPU and memory available, like how many or how much CPU and memory are available. And application master is responsible to execute your application, right? As you can see that we could separate all duties or all tasks by resource manager into 4 JVM, Java virtual machines. So in terms of availability, so we could, sort out the problem of resource manager, right? If you miss that, if you lose that, if for any reason, if you have no, availability of resource manager, just go ahead with Yarn. As I said, if you install Hadoop 2 or 3, that we work, we will work with Hadoop version 3. Means Yarn is there. We don't need to be worried. So but we need to get also high availability for name node. So if you lose name node for any reason, it means you will lose your data, right? So it's gonna be crash your cluster. So how to sort out? So in Hadoop version 1 and 2, we have still this problem. Hadoop version 1, had lots of problem, but Hadoop version 2, it comes up with active passive setup. It's going to create one active name node and one standby name node. It means if you lose one, the active one, there is standby mode, right? Then you can keep, avoiding name node failure, but there is no guarantee because you may have also lose your your passive mode, your standby name node. But in version Hadoop 3, as I said, that we will work with Hadoop, version 3, there is one active name node, 2 passive name node, and 5 journal nodes to stop catastrophic failures. It means in Hadoop version 3, really there is no chance to lose your name node. So name node machines, which is run active and passive mode, this is come from Hadoop version 2, right? But in journal node, it's really lightweight of name node, and Yarn is going to be collected, right, within your same cluster for to stop catastrophic failures, right? It's going to handle, it's going to get back to the active mode, right? These are what exactly you need to know. And another approach here is called intra-data node balancer in Hadoop version 2. So we talk about data node. I've said that for data node, Hadoop is going to divide your data into, let's say, 4 partitions. Okay, and you have, let's say, or let's take this example. Let's say you have 3 disks, right? And you want to divide your data into 3 partitions. So there are different, strategies. One strategy called round robin. So round robin, it's not going to look after your existing, data within a disk. So as you can see that this blue one means this disk is somehow full, but this 2 is completely full. Let's say completely full, but this 3 is empty. But if you take round robin as data partition strategy, round robin is going to be very fair and distribute data across the disks. So, but in this case, it's not really helpful, right? Because disk 3 is, empty, and we didn't use that, so, but if you use this available space volume, so how does it work? It's going to calculate the availabilities. It's going to see how these are available. So since this 2 is somehow full, it's going to ignore it. and put 2 blocks here and 1 block here. It's much, it's much smarter. So these are some other, techniques also, FIFO, right? LIFO, and many more strategies. But 2 frequently used are round robin, right? And available space that we can see that. So let me see here. Okay, let me move forward. And guys, this is Hadoop ecosystem. So guys, really big area, Hadoop ecosystem. Let's elaborate more that why we need this ecosystem. So here we talk about, this one, HDFS storage. Alloxio is another one, the cloud-based version. We talk about, Hadoop Yarn, which is the job, or let's say resource manager, and you can use Mesos if you have data center, right? For data center, you need to have much, robust and efficient resource manager for data center. So job scheduler, let's say you want to run hundreds jobs, like doing lots of processing. You need to have, job scheduler like Uzi, like Airflow. You can use that. So, and you need a coordinator. You need a manager to get control, to take after or look after all these components. We call it Zookeeper or Ambari, right? You can do that. And also we have security part we call Apache Ranger. Is going to take over, authentication, authorization, talking about privacy, integrity, and many more that you can take over. And data format, you can work with any data format on this case. And metadata, which is relevant to name node, right? If you are working with really huge data as data center, right? Let's say you have 100 data center that you want to keep control of those metadatas, you have to work with Apache Atlas. So these are the components that you need to take over, you need to learn. So, but we need to know what these, these are, why we need them, right? These are in the middle, right? These are really important. So let's tell you why we need that. So if you remember, I've said that the processing phase, it's going to be handled with map and reduce, right? Map and reduce Hadoop, right? Okay, let me take this example from IBM. Let me check. I'm looking for, not here. Let me go to the images. Let's take this one. So I can right, this one. Let me copy. Okay, let's explain here. Let me take a screenshot. Screenshot. Something like this. Okay. Yeah, nice. Okay, this is a MapReduce phase, right? That we discussed. I want to give you a reason that why we need those, ecosystem for Hadoop. So here, let's say this file is a huge file. Let's say this is like that example, 1 GB file, right? So first of all, we have to divide data into partitions. So this is partition 1, 2, 3, and 4. So where they are in data node, right? In hard disk, right? And where is metadata? In name node, right? This is okay. This is easy now. We learned that. And then if you remember, I've talked about mapping and reducing, right? This is going to be happen with task tracker. So let's say I have this file. I want to count the number of unique words. So first of all, I divided data into the partition. Then we, as a programmer, as a developer, we have to develop a code for mapping and reducing. So mapping and reducing, you have to write them down with Python, Java, whatever, and then send them to Hadoop, and Hadoop is going to execute them. Okay, so in this case, we would say that we can count, each word at each partition. Welcome is 1, 2 is 1, Hadoop is 1, class is 1, Hadoop is 1, the number of occurrences, right? Is 1, and so on. So we could do that on each partition. So then we have a shuffle. Shuffle is a phase, is going to be done automatically. You don't need to be worried about that. It's going to be done automatically. However, you can have your own shuffling method. But I mean, if you miss that, don't worry. I mean, Hadoop is going to take it over and it's going to put the similar keys together. So I've set keys. Here, as you can see that mapping is key and value. So if you want to execute, or let's say a develop application under map and reduce. So this is map and reduce, right? Please make sure to remember map and reduce, which is processing stage. You have to convert your problem into key and value. Why? Because of aggregation. Because at reduce phase, you have to aggregate the result. The only way you are able to aggregate the result is key and value, right? And then here you can, aggregate based on the keys, right? And then get the result. This is the result that you can get out. So there is really big problem, key and value. So let's say I want to write a SQL query. How we can convert the SQL query to key and value? Really impossible, right? Let's say I have for loop. How to convert it to key value? I want to have conditional statement. How to convert it to key and value, right? So because of all these impossibilities, we have to think that how we can sort it out. Guys, it's really difficult. It's not, no one recommends to go through this mapping and reducing. To find the solutions, right, to make it, achievable, this map and reduce is really big deal in Hadoop. How to sort them out? There are two solutions. One solution is Hadoop ecosystem. I want to explain. And second solution is a Spark. So Spark is just for, processing stage. That's going to help you to handle these key and value map and reduce. So also we will go through Spark as a part of the course, and let's take you into Hadoop ecosystem. So for Hadoop ecosystem, as you can see here, let's say you want to have SQL. That example I discussed for, in this case, let me use this color. So for SQL, can you see that you have to work with this component, or let's say with this ecosystem? Hive, Drill, Impala. These are for SQL queries. What does it mean? It means you have to get your data into Hadoop, right? And then you can use Hive and Impala. They're gonna to convert your query into map and reduce phase, or HBase. If you have a search engine, use Apache Solr. If you have, this data piping also is for, collecting data. Let's say you have, huge size of data inside, let's say inside your Microsoft SQL or inside your Oracle server. How to bring them into Hadoop? You can use, Scoop. That's a part of the course, right? And then Flume is also for unstructured data collection, and Nife is for, is also another open source service for data piping. Even if you want to use machine learning, right? For machine learning, how you want to convert k-means, for instance, into keys and values, really impossible, right? So in this case, you can simply use Mat library or Mahout, right, to convert your, machine learning techniques to, map and reduce phase. And the Spark is, is something different that we will explain. Also for scripting, you can use Peak and so on. So frankly speaking, Hadoop ecosystem is really huge ecosystem. It's a new world to data management, data processing, and if you want to be expert on this area, this is one of the well-paid jobs in data. And since you are really at the beginning of this topic, big data, you can take this lesson, this ecosystem. You can go through the most components. We will cover the most components, and some other components you can take your own self-study to get well enough knowledge out of this Hadoop ecosystem, and so on. Also, there would be Spark on top of that we will discuss about. So big companies offer big data services. So we will work on our local machines, right, for big data processing. But there are companies, these are, let's say, uh, uh, providing cutting edge data solutions. Cloudera, we will work with one of Cloudera services, and Databricks, the US-based data solutions, IBM, and many cloud services, Amazon, like Amazon, AWS, Google Cloud, and Microsoft Azure, right? You can use for big data. They have their own big data clusters using Hadoop, right? You can learn. Also, this is online mode. So guys, for most of them, right, you have to pay, right? These are paid services that you need to pay to be able to use big data services. But we will go through Hadoop, right? And we will install Hadoop on our own single machines. And you would see that how you can set up Hadoop on your own single machine. And then you can work with huge size of data. Or for your own self-study, let's take it as a self-study, right? That you can go through these, companies, check their websites, their solutions, platforms to see how they provide Hadoop and also Spark. That's going to be a part of the course, and how they provide the solutions. So Hadoop case studies, there are like many case studies. So I want to ask you please to take it over and go through like 5 or 6 slides to see and to learn these case studies in industries. For instance, BT, right? They are using Cloudera to be able to, for what reason? To cut down engineer callouts. And you would see how they use, Hadoop for big data processing. Like if you read the story, like used to create a new services called View My Engineer, SMS and email alerting system that lets customer track the location of engineers, and vehicle maintenance and many more, right? They use Hadoop to process all this stuff. Why? Because they have huge demand. They have huge number of customers. Royal Bank of Scotland. So also you can go through this story to see how they work. So the problem was they have to have 250K chat logs plus metadata per month. Still huge size. So also data was unstructured. So they use Hadoop to collect data at the first stage, right? And then for processing, they can use, Hadoop ecosystem in terms of their requirement. For instance, if they want to have SQL, they have to use this one. If they want to use machine learning, they have to use this one. And or maybe they want to work with Spark. So, I mean, this one also Royal Mail, right? So they also use Hadoop. You can go through the story to see why they need to use Hadoop. British Airways, they, they work on Hadoop from 2015. And also you can go through, this story to see why they need to use that. So these are really nice case studies. Western Union to transfer money, right? So they have Hadoop-based data analytics platform from Cloudera. So can you see that, guys? Cloudera is really well-known, let's say, #1 data provider, because they give you different solutions for big data. Because if the size of data get increased, then you need to have more workstations, right? If you want to avoid paying for workstations, you can use cloud services on Cloudera. So as I said, it's a paid service and so on, right? And then King.com, and for the Candy Crush, they created Candy Crush Gaming, and you can go through also this story to see what they have done with Hadoop. Expedia, I think, and I believe you heard about that. This is for flights, for hotels, for entertainment, and so on. So there is also another story that how they work and how they use Hadoop, and hotels also how they use Hadoop. Also, you can read the problems they are facing and so on. So please take them in your own self-study. Marks and Spencer, the giant retailer in UK. So also they talk about the problem they have been faced with and how they use, big data approach. Tesla, of course, 100%, you heard about that. So they are using Hadoop cluster and so on, right? And yes, I try my best really to go through big data and to see what is exactly big data and what is Hadoop, why we need Hadoop ecosystem. And two important components, HDFS, we are happy with that, but we are not happy with MapReduce because of the way we discussed that we can't develop complex applications using Map and Reduce. To overcome Map and Reduce, two solutions, using Hadoop ecosystem or using Spark, right? So, and I hope you enjoyed the session, and see you guys